Alright, I know that's kind of weird I ended the video right in the middle of a problem, but sorry. Okay, now we're going to work with some reference angles that are in radians. So, I want you to start by making your XY axis, only this time these are going to be labeled with pi's. So remember, if you go all the way around, you end up at 2 pi. Once, or halfway around, is pi. So if you notice, since this angle is over 3, you could call this, okay, you can't see that, you could call this 3 pi over 3, which would make this 6 pi over 3. Alright, so then 5 pi over 3, remember every angle starts on the positive x-axis, 5 pi over 3 is going to go all the way around to about right there. Then I have to find my reference angle. It starts at the terminal side and it ends on the x-axis. So there's my reference angle. So it ended at 6 pi over 3, and I'm going to subtract the angle, which was 5 pi over 3, which gives me a reference angle of pi over 3. So the reference angle is pi over 3. Let's try another one. Alright, 7 pi over 4. Alright, smaller here. Alright, so if I start labeling these, remember if you go all the way around, it would be 2 pi. If I want to make that over 4, that's going to be times 4, over 1. That would become 8 pi over 4. So if you notice, 7 pi over 4 over here would be 4 pi over 4. Start on the positive x-axis. 7 pi over 4 is going to be about right there. It goes all the way around. Another thing you could probably put on here, remember this is pi over 2, there's pi, and this is 3 pi over 2. If you wanted to even see how close it was, you could multiply those by 2 to get 6 pi over 4. So you can really see that 7 pi over 4 is right in between those. Alright, the reference angle ends on the terminal side and on the x-axis. So this time I'm going to do 8 pi over 4 minus 7 pi over 4 to get a reference angle of pi over 4. Alright, 5 pi over 6. I'm running out of room here. I'll do this one right here. Okay, so 5 pi over 6. If I label some of these, I've got pi over here, or 6 pi over 6. I'm not going to have to go any further because 5 pi over 6 is smaller. Up here I've got pi over 2. If I want to change that so the denominator is 6, multiply by 3. So that's really 3 pi over 6. So you can see that 5 is going to end about right there, 5 pi over 6. Start on your positive x-axis. There's my 5 pi over 6 angle. So my reference angle ends on the terminal side and on the x-axis. To do this, I'm going to take 6 pi over 6 minus 5 pi over 6 to get a reference angle of pi over 6. Alright, one more here. 19 pi over 6. Squeeze this in right there. Okay, so 19 pi over 6, I have, let me get a different color here. Alright, so I have 6 pi over 6 here. If I go all the way around the circle, I will end at 2 pi or 12 pi over 6. So notice, we've already had to go around a full circle. So 19 pi over 6 is actually bigger than 2 pi. So one thing you might want to do if you realize it's that big, you can do 19 pi over 6, and I'm going to subtract a full 2 pi. A full 2 pi over 6, which is going to put me at 7 pi over 6. So then I don't have to make all those curly cues and go around, because as long as I have the same angle, so it starts and ends at the same spot, that's really all I need. Okay, so now 7 pi over 6. If I start here, if I go all the way to here, I'm at 6 pi over 6. I need to go a little bit further. Remember, down here is 3 pi over 2 My pi's are getting uglier. 3 pi over 2, or if you want that to be a 6, multiply them by 3. So it's really 9 pi over 6. So you can see that 7 is about right there. Alright, if I want my reference angle then, my reference angle ends right there. I was doing red before. It ends where on the terminal side and the x-axis. So there's my reference angle. In order to find this, I would do 7 pi over 6 minus 6 pi over 6 to get a reference angle of pi over 6. Alright, lots of examples there, but hopefully that will help. Alright, let's go on. Notice, I added something extra down here that you do not have on your notes. This is what we're going to work on very soon. It's a piece of what's called the unit circle. So if you want to sketch this in underneath, you can. I really like this. I think it helps a lot. And I know a lot of the pre-calc teachers will refer to this. Okay, so the steps. Step 1, what I'm going to have you do first is I'm going to have you sketch the given angle. So we've practiced this quite a few times. Hopefully you kind of got it. So I want you to sketch the given angle first. Next, I want you to find the reference angle. And we practiced that quite a few times. You guys should be pros at this by now. So find the reference angle. Remember, that's the one that looks like this, theta with theta prime. Third, I want you to graph the point. And that's what we were doing at the beginning of these notes. You're going to graph the point. And then you're going to use the chart. Graph the point, use the chart, or now there's different charts. We've got this chart here and that unit circle chart there. And last, I want you to find the given function, or find the trig function. So with these, I'm not going to have you find all 6. You'll just find the particular one that you need. Alright, now, a couple things I want to point out. You're going to learn a lot in pre-calculus, but one thing that you might see is this ASTC. When I learned it, I learned all students take calculus. Some call it ACTS. If you start right here and you go down, ACTS. A bunch of different things. All this means, the A just means that everything is positive. It's all positive here. Sine, cosine, tangent, secant, cosecant, cotangent. Everything is positive, and the reason is because your x value is positive and your y value is positive. S, this stands for only sine is positive. If sine is positive, then cosecant is also positive, but the reason this is because your x value is negative, because it goes back, and then your y value is positive, negative, positive. Down in the third quadrant, tangent is going to be the only positive one, along with its inverse, cotangent. But the reason for this is because your x and your y are both negative. And in the fourth quadrant, cosine is positive. And the reason for this is because your x value is positive and your y value is negative. So if you were to plot an ordered pair, it's depending where they show up. Now, if you remember, cosine is always going to be your x value. Sine is always your y value. Tangent is sine over cosine, or y over x. And then that correlates to what I just kind of showed you there with where certain functions are positive. Alright, now, we've got this chart to fill in here. I am actually going to start over here on, I've got a little extra chart that you don't have on yours. Alright, so we know over here we have 2 pi, or 0, and that is the ordered pair. You go over 0, or over 1, up 0. Sorry, I was saying that backwards. Over 1, up 0. And actually, up here I've got pi over 2, and that goes over 0, up 1. So I'm just showing you the first quadrant here, so I guess technically we should just call this 0 instead of 2 pi. If you go all the way around, you'll end up at 2 pi, but we'll just do the first quadrant. All right, 30 degrees. If I change that to a radian measurement, remember you can always do 30 times pi over 180. You will get that that's pi over 6. So 30 is the same as pi over 6. Now, if I draw a triangle here, so that's 30 degrees. This thing is called the unit circle. The radius is always going to be 1. With these, we can do our 30, 60, 90, or HSL rule. I'm actually going to draw this triangle out here so it's not such a mess in there. Alright, so you've got a 30, 60, 90 triangle. We can do the HSL rules. I'm going to draw a 30, 60, 90 triangle out here to the side, and I'm going to erase this, get rid of this, just so it's not so messy, but you see where it came from. Alright, let me put my pi over 6 back. Alright, so anyway, this radius is always going to be 1. This is called a unit circle, so the radius is always 1. Alright, so then my short leg is half of that. Half of 1 is half. My long leg, I multiply by radical 3, so that's going to be radical 3 over 2. Now, you'll see here that this was my x value. It went over radical 3 over 2. So it went over radical 3 over 2, and it went up 1/2. This was my y value. So I went from 0, 0, I went over radical 3 over 2, up 1/2. Some people like it on a chart like this. So the x value is radical 3 over 2. The y value is 1/2. Alright, let's take a look at this triangle here. So if I make this triangle, again, you have another 30, 60, 90 triangle. It's just that this time it was turned a little bit. So let me make this out to the side. So this triangle, there's my right angle, this was the 60 degrees, remember, that's always 1. This time, the long leg is over here, so this is radical 3 over 2, and the short leg is 1/2. So this time, the x value is 1/2, it goes over 1/2, and it goes up radical 3 over 2. So again, we can fill that in on the other chart. Let me get rid of this triangle here, it's kind of messy. By the way, this is pi over 3. If I did 60 times 1, or pi over 180, I would get pi over 3. I told you guys this was a lot of information. Alright, last one, or actually I never wrote it in on this chart. So this would be the x value, cosine is 1/2, sine is radical 3 over 2. Alright, oops, it stopped recording, sorry. Alright, so I just drew my 45, 45, 90 degree angle. The hypotenuse is 1. To get to the one of the legs, you have to divide by radical 2. So if I do 1 divided by radical 2, 1 over radical 2, simplifies to radical 2 over 2. And both the sides are the same. So I've got radical 2 over 2, radical 2 over 2. And I can put that on this chart as well. Alright. With this chart, some people notice a pattern that this goes 3, 2, 1, 1, 2, 3, and you just have to remember what's under the radical. They're all divided by 2. Alright, that looks like I just made those negative now. Let me get rid of those. Okay, tangent is sine over cosine. So, yikes. Tangent sine over cosine, so then you would just have to take your y value divided by your x value. So, if I did 1/2 divided by radical 3 over 2, I would end up, if you simplify that, you get radical 3 over 3. If I do radical 2 over 2 divided by radical 2 over 2, I get 1. And if I do radical 3 divided by 1/2, I get radical 3. Alright, a lot of information we'll be working with this.